Okay. So let's get rolling here. We up on both screens. I'm sharing my screen. I'm recording. All right. So I think everybody online, I think, can hear me. Looks like my mic is working. All right. So for starters, I'll remind you that I will not be here on campus next week. So we will not meet normally for class on Tuesday or Thursday next week. But next week should be a pretty busy week for you in this class. Um, so what I did is I already put up a homework assignment that is due, um, what do I have it due? I think Thursday of next week. Um, and at the end of the day, actually, if you turn in late, I don't care. But effectively what I did is I created a assignment that has a whole bunch of functions to work on. Practice functions that I think you will find to be extremely similar to the types of questions I will ask on the midterm. All right. What I'm going to do is I'm going to, the midterm's already written. I already have it uploaded. It will unlock at 10 a.m. on Tuesday. So before this class on Tuesday. I know the other assignment's not due till Thursday, but you just have to take that test and submit it before 10 a.m. the following Tuesday. So you'll have a week to figure out when is the exam is designed to take, let's say, an hour. But as you've already seen, sometimes beginning programming, things take a little longer than you would have expected. So what I think I set the time limit as like 150 minutes or something like that. It should not be a time stress. If you're running out of time, it means you're probably not where you need to be at this point, and this is your wake-up call, blah, blah, blah. All right, so you can start taking that exam as early as 10 a.m. Next Tuesday. I would encourage all of you to wait until you've gone through all of the assignment that is due on Thursday next week, practicing all those things, and maybe do the exam over the weekend or Friday or even Monday, whatever it is, just sometime before class the following Tuesday when it's due. I'll go over it then in class. So I'm effectively giving you a whole bunch of practice that is extremely similar to what the exam will be. So if you work hard on that assignment, kind of get into groups, maybe ask some seniors for help. I know we have the computer science study group every week. What day is that? Mondays? Somebody said Mondays? Yeah. So right across the hall, and all those students have had this class. They'll be willing to sit down and help you if you have questions. So I strongly encourage you to take advantage of that. The midterm will have exactly 10 questions on it, and there will be similar questions to what's on that assignment. There'll be a mix between kind of simple functions to write and a little bit more complex functions to write. You'll see a pretty similar mix in the assignment. So I would say if you feel very comfortable with that assignment, you would do quite well on the midterm. Remember my policy that if you do poorly on the midterm and you do better on the final exam, I'll replace whatever you get on the midterm with what you got on the final exam. All right, so none of these things are permanent things. Again, I'll just keep reminding you, I know you're spending more time than you're in this class, and you probably are in many of your other classes. You probably feel like you're not very good at this yet, at least for most of you. Part of the process. Day one, I said programming is like a sport. All you can do is put in the reps. All I can do is keep showing you things to practice and try to be as reasonable as possible when it comes to grading, because nothing's going to replace those reps. Punchline. Later on, you'll thank me with your paychecks and donations. I do accept later. You know, I offer the bribes now, but I expect an investment later. All right. So any questions about any of that? Go ahead.
So the midterms, like, is it a built-in Blackboard quiz somehow?
Correct. Yeah. So you'll go into Blackboard. It'll show up as midterm exam or something like that. There's 10 questions. You'll say, you'll click start now. And once you say that, you're locked in. So make sure that you have set aside 150 minutes to work on it. I doubt it will take you that long, but it's your time if you want it. There's already notes on there in terms of what you're allowed to do, what you're not allowed to do. So I don't want you Googling stuff. I don't want you using ChatGPT where you just paste in the question I'm asking, write a function that does X, Y, Z. You paste it into ChatGPT and you just submit whatever it spits out. You've got nothing out of that, right? It costs me nothing to give you a better grade than you probably deserve. So you might as well get as much learning out of it as possible. You're not helping yourself at all if you just let something else do all the work for you. But what I did say is you can use your notes, like the keynote presentation or any notes you took here in class. I'm okay with you using those on the exam, kind of to remind you of a concept. Because what I want to see from the exam is kind of what is your current level of competence, not did you remember some little thing I mentioned in class. I'm not asking you to memorize stuff. I'm asking you to apply that knowledge. Okay, so you can use your keynote. You can use any notes you took. Just use your best judgment. If it feels like cheating, don't do it. Okay, if it feels like you are giving yourself the information you need to perform, to show me the best of what you're capable of doing on your own, I'm probably going to be fine with it. All right, if you need to do a quick little Google search for a concept that you don't know what I'm asking in the question, nobody's getting shot. All right, just don't cheat. You're only hurting yourself. Got it? Go ahead. So what I'll do is I'm going to go through all of those. Well, the question was, will there be lectures next week? And I do see the person online with the hand up, so I'll come to you in a second. So what I'll do is I will go through and video record me doing all of the practice questions. So if you get stuck, you'll have something to reference. So I'll do that. I'll actually probably have that up today or tomorrow, maybe, just to get it out of the way. So if you want to peek early, if you get stuck, you can. But again, I already know how to code it. So you're only hurting yourself if your whole goal is just to get it done. All right, but I'll have all the solutions up so you can look through it. I'm also going to be available via Slack, text, email. I'll be around all next week. I just physically won't be here. So if you do have a question, feel free to ask. I'll help you the best I can remotely. All right, other questions? Seem reasonable, seem fair. Okay. Sorry. As I remembered, somebody online had their hand up. All right, who we have? Nico online?
Yeah.
Go ahead.
As part of the resources that we can use for the exam, can we use past homework assignments as kind of a guide if we get stuck? Or you want to kind of stay away from
Okay,
past homework?
so let me qualify it. And I guess this will probably fall underneath the same thing I said before. I guess I don't technically mind if you use a past homework assignment to kind of give you a little bit of structure. But the danger of that ends up being that if you haven't really learned how to do this stuff, what you end up doing is, regardless of what question I ask, you just regurgitate something from a previous assignment. I get the for loop that does something from some homework assignment because you haven't practiced enough to even know what I was asking. So I guess generically, if you need to glance at some code just to get your mind in the right area, I don't necessarily care, but I want you to problem solve through it yourself. And I'm expecting there to be bugs because I don't want you to use online GDB to test it and stuff like that. So I'm expecting to get some typos. I'm missing semicolon here and there. I want to know, are you largely wrapping your mind around the programming process? I know that you'll run it through the compiler several times if you were doing this for real, have it point out your couple of bugs, fix them up, move on with life. Okay, it's pretty clear when somebody mostly knows what's going on versus mostly doesn't know what's going on. So again, if you feel like you glancing at a past assignment is going to kind of get your mind in the right area to answer the question that's in front of you, I don't care. Just don't copy from a previous assignment, because to somebody who already knows how to program, it's very, very obvious. So I would just give you a 0 and move on, not waste my time grading it. Go ahead.
Okay.
Typing this into Blackboard, or should we do it on online GDB?
Yeah, I would say it's up to you. I mean, if you want to use online GDB just for formatting, that's fine. Just don't run it. Or you can just type it directly into Blackboard and give me kind of the best formatting you can. Or if you want to use a programming text editor to make your code look cleaner, just not test it, that's fine too. So whatever is most convenient for you, but ultimately I want your code in Blackboard, not a link that leaves Blackboard. All right, I think there was one more question online. I saw another hand up. I don't remember who. Oh, it's Catherine. So Catherine Spencer, hand is up.
Um, if we do bad on the final, do you replace that with the midterm, or is it the other way around?
Only the other way around. Yeah, you can't do well on
Okay.
the term and then bomb the final. Basically, it's you get every opportunity to show me you've learned the stuff, and hopefully anybody who hasn't been either catching on quick enough or has maybe been slacking at midterm time, they get the wake-up call at the midterm, and it doesn't destroy your grade forever. So you get you get a redo on the final, but you can't do well on the midterm and then coast the rest of the semester knowing that you have a 97 already in the final, regardless of what you do. So only one direction. All right. Any other questions? All right. Sure. This homework assignment. Okay. Yeah, they asked the questions in the chat. Okay. So I mentioned today that we were going to, so we didn't have an assignment due today, but I kind of I told you what we were going to work on. So maybe you can get a jump start. We're going to kind of look through the problem of converting from a base back to decimal, the other pattern. Again, we're kind of practicing this idea of how do we solve these problems? How do we look at a real life problem, make sure we understand it, then break it down into the individual pieces so that when we actually go and write it, it all kind of comes together. We're trying to train ourselves out of just immediately looking at the keyboard and starting to code before we even know what the problem we're trying to solve is. All right, so we'd like to write a function, maybe called base to decimal, something like that. And this guy would takes a string representation of a number and an int representing what base that number is currently in. It should return an int that is the decimal equivalent. So I'll put in parentheses here, the base 10 of the number that was passed in. All right, so makes sense, the problem we're trying to solve at the high level. All right, so now let's go and remind ourselves about this pattern. Let's maybe do a couple of conversions real quick by hand, just making sure we know how to solve it before we try to write code that can solve it. All right, so let's look at an example. Let's say our input was 101110 and 2. So we took the string representation of a number, and then I'm advertising this number is actually base 2. Okay, so 2 inputs, string representation of the number, and then what base that number is in. And the reason we have to give the base is even though we might glance at that and be highly suspicious that that's a binary number, is that also a legal decimal number? That's 101,110? that number is legal in many, many, many bases, right? So we do need it to have told us the base that we are currently representing the number in. So we want to convert 101,110 from binary to decimal. That's what we're doing. So we're going to go ahead and write this number out and remind ourselves of our pattern. Okay, remember this is the ones place, the twos place, the fours place, eights, 16s, 32. So that's the 32's place, the 16's place, the 8's place, the 4's place, the 2's place, the 1's place. And if it's helpful, remember this is 2 to the 0th place, 2 to the 1st place, 2 to the 2nd place, 2 to the 3rd, 2 to the 4th, 2 to the 5th. And that's always going to be the case. The far right value is always the ones place, and that could be rewritten as the base to the 0th power, which is always 1. The next place would be the base to the 1st power, which is the base. The next one is the base to the 2nd power, which is the base squared, so on and so forth. Go ahead.
Yeah, so for the like the title, you got that comma, does that just mean that you're converting something?
These are the inputs. So on the previous screen, I said that you're going to have a function called base to decimal. This is the example of me calling that function, passing it the first input, which is a string, and the second input, which is an int. And that's what I had said. Takes a string representation of a number and an int representing the base. So I'm showing how I might call that function to solve this problem. All right, so now we do our math. So this is 32 times 1 plus 16 times 0 plus 8 times 1 plus 4 times 1 plus 2 times 1 plus 1 times 0. Now, I know you could have glanced through those and pretty quickly just ignored the ones that have zeros, because 0 times anything is going to be 0, but we'll keep everything. It's not going to hurt anything. So this is the number 46. So our function in this particular case would return 46 as an int. All right, let's look at one more example. Let's say I did 1, 2, 6, 7, and this was base 8. All right, so we're gonna write out our numbers again. So 1, 2, 6, 7. This is the ones place, the eights place, the 64's place. Was it 256? 512's place. So this is 512. 64, 8, 1. So we do the math. This is 512 times 1 plus 64 times 2 plus 8 times 6 plus 1 times 7. 695. So our function in this case would return 695 as an int. Make sense? All right, let's do one more just to remind ourselves what happens when we start throwing letters in there. So we'll use our favorite base 16 number, BAD. So we have BAD that's currently in base 16, and we want to convert this to decimal. So when we write our number out, we have B, we have A, we have D. This is actually an 11, a 10, and a 13. So this is the 256 place, the 16's place, the 1's place. So this is 256 times 11 plus 16 times 10 plus 1 times 13. Oh. 2989. So this guy would return 2989. All right. So we all remember now the pattern we're trying to implement. We've had a couple of examples. We threw a couple of curveballs in there with the with letters. So we knew that we needed to convert the B to an 11, the A to a 10, the D to the 13. What should be going on in our head right now is maybe we're going to need a little tool to do that conversion, maybe a quick little function that does the mapping for us. So even as we were going through that, we want to kind of think of some of the stuff we're going to need. All right. So as we went through this, we know that this was the 1's place times the base 16's place times the base, the 256 place. So we see how it's jumping. Similar on this one. This is the 1's place times the base is the 8's place times the base is the 64's place times the base is the 512's place. In this case, the base was 8. Same thing is true here. This is the 1's place times the base times the base times the base times the base times the base. A pattern. And since we're doing something over and over and over again, probably going to be a loop. Okay, it's starting to give us the tour of what we're doing here. Okay. So let's go and start writing some of this. Where is my, oh, here it is. All right, now let me, well, I'll just cut this. All right, let me make sure we have a functioning hello world. And we do. Okay, so we have a working program here. We've mentioned that we want to write a function that returns an int called base to decimal. And this guy is going to take a string number as a parameter. And it's also going to take an int base as a parameter. Okay, remember I prototype it at the top and then I implement it down below. Nothing says that we couldn't implement it before main here still. I typically say good programming practices, do all your prototypes beforehand. And remember, prototyping, it gives us the ability to have functions that call each other. We don't have to worry about, well, was one function defined before the function that needs it, so on and so forth, because sometimes you get circular definitions. So if you always just let your compiler know that, hey, here's the stuff that will be implemented, then it can put all of it into its symbol list so that later on when it runs into real stuff, when you're actually calling those functions, it's heard of it. All right, this is only something that we need to do in our older programming languages today. But frankly, it's something that I think has been lost. I even mentioned this last class, I think, when we talked about JavaDoc a little bit. When Java first came out, they had a documentation generating tool that came with it that nobody used. It does produce pretty good documentation. All of the Java documentation is among the easiest to find stuff and easiest to read. In fact, I might even say one of the reasons the Java programming language has become so popular is it's probably among the best documented programming languages out there. You're probably already seeing C++ is among the worst documented programming languages out there, and not even its fault. You have to consider it's gone through 15, 20 different renditions. You know, the string we're using today is like 4 levels of evolution removed from the original strings in C++. So it could be so much worse than we're dealing with in here. The C++ strings we're working with in here are joys to work with compared to the old the originals. All right, but you know, point is that as you become a more experienced programmer, you will value good documentation, because how many of you think you're going to memorize the entirety of all these languages? None of you. I've literally been programming Java since the day it came out, which is before most of you were born. What percent of Java do you think I've ever used? I would guess less than 20%, probably far less than 20%. When you look at the Java language, there are just so many libraries that come with the language for very specialized things that I've never run into a situation where I needed to use them. Make sense? But by knowing how to program and knowing how to read the documentation, you've unlocked that entire language to open. You've opened up that whole language because now you know how to use this stuff, even things you've never used before. It's kind of like walking into Home Depot, getting out to your car, and you know you have a tool that will solve the problem that you need it to solve, even though you've never solved this problem before, but you already know exactly how to use that tool. Make sense? That's the power of being able to read documentation. That's something that should be really high up on your priority list as you become a programmer. Because I promise you, when you go out into industry, you're going to be solving problems using libraries you've never seen before. In fact, at a lot of places, you're going to be using libraries that they wrote in-house that nobody has seen before. And you're going to have to use those things, use those tools. All right. So these are important skills. So Java is really well documented, and that's probably why it's been so successful, because it does have some other organizational weaknesses. For example, most of you have probably heard of C# before. It's one of the .NET programming languages. These are the Microsoft languages. You know, as much as we might demonize Microsoft for a zillion different things, while the Microsoft languages are not as well documented as Java, they're pretty well documented. But what Microsoft has done really, really, really well is integrating all their different technologies into a single tool, Visual Studio. So that means when you are a developer at a company that's a .NET shop, everything is done through a single set of tools that Microsoft lays out there. And there's power in that. Whereas Java has always been disjointed. You know, if you need one thing for server side stuff, another thing for client side stuff, 20 different technologies. You got a couple in there that compete with each other, that have disappeared and were reborn over the years. So as you get into this, you'll start getting your preference for languages, but the preference won't have anything to do with the programming side of things. It will be how convenient is it for you to just pick up and wield that language. That makes sense? All right. So we have our base to decimal prototype here. We'll go ahead and implement it below. Okay. So now we know that we are going to have to work through our string. Let's go back here. We know we walked this string from the end towards the beginning, because this is the ones place times the base got us the 16th place times the base got us the 256th place, right? So there seems to be a convenience of going to the end of the string and moving towards the beginning of the string, doing something each step of the way. Okay, so let's just do that first part. Let's just write a loop that goes from the end of the string to the beginning of the string. Don't do anything extra. I promise you, you take these little baby steps like this, eventually you'll fill in the gaps quickly, right? You know, you'll eventually won't sit here and like, when is he finally going to write the next stupid thing? You know, take it slow until it's completely annoying, and then you know you're ready to take it faster. All right. So we're going to write our loop that goes from the end of number towards the beginning of number. How many characters are in number? Number.length, number of characters. Okay, so we're going to have for int I is equal to, what is the last legal position inside my string called number? What's the last legal index? Strings are zeroed index, so if there's 5 characters in the string, what's the last legal one? Length minus 1, 4, in my example. So we're going to start I off at number.length minus 1. So for example, if this was our number right here, BAD, this guy has a length of 3. The last legal digit is 2. This is bucket 0, bucket 1, bucket 2. Okay, so we're going to start at the end. We're going to keep going as long as we haven't walked off the beginning. So as long as I is still at least a 0. And each time through, we'll decrement I by 1. Now, again, remember, this loop right now has almost nothing to do with a string, other than we just use the length of a string as part of our counting. This just takes I on a voyage between length minus 1, that number, and 0. What we choose to do with that number is now up to us. All right. So what we're going to do initially is let's just go ahead and display the character we're looking at, just to prove to ourselves that we are walking the string in reverse. All right. So we'll do a cout number at bucket I. Oh, here, we'll do it all in one line. And then after the loop, we'll spit it out. All right, so we'll walk backwards through the string. We will output each individual character as we hit it. So if I were going through this one, it should be D-A-B. It'll give us a dab, right? All right, so what will the output of this program be? Nothing. Why? All programs begin and end with main. We've done a whole bunch of fancy stuff writing functions all over the place, but we never actually called this guy. So we're going to call our base to decimal. We're going to pass it our BAD and our 16. We probably want to get our answer back from it, even though right now we're not actually returning an answer. I have advertised I'm going to return an answer. So for the moment, let me just return a -1 for no good reason. I don't have anything better to return than that right now. We're just testing. All right. So I've advertised I'm going to return an int. It's called base to decimal. It takes a string and a number as a parameter. All I'm doing right now is I'm writing a loop that will display the characters in that string in reverse. So there's my gap. All right, so we know we're walking into reverse now. So far, so good. Go back to our picture here. Well, what are we doing as we're walking in reverse? Well, we know we're having to keep track of the place we're currently looking at. This is the ones place, times the base is the 16th place, times the base is the 256th place. So we probably want to create a variable that allows us to take that voyage, right? So before this loop starts, I'll create a variable called place, and we'll start off at 1. We know that the ones place is always the far right. So rather than print out the character we're looking at now, we're going to go ahead and print out the place. And then we'll multiply the place by the base. So place started off at 1. So right here, we printed off a 1. Then a 1 became a 16. Spin back through, we print out a 16. Then the 16 became a 256, which should line up to 1, 16, 256, giving us the values that we're interested in there. So there's our 1, our 16, and our 256. All right, so far so good. All right, so now what do we do with these numbers? As we have these numbers, what do we do with them? Well, we have to multiply them by the value of each character in our string, the numeric value in each character in our string. All right, well, we happen to know that we're going to have strings filled up with things that are only numbers, like 1, 2, 6, 7. We're also going to have strings that are filled up with letters like BAD. We need to have a way of taking an A and converting it to a 10. We have to have a way of taking the char 2 and converting it to the number 2. So it might be helpful for me to have a function that I could pass an A to, and it would spit back out a 10. That I could pass the character 2 to, which has an ASCII value behind the scenes that's not 2. But I want to pass it the char 2 and have it spit out the number 2 to me so I can do math with it. That would be a handy function to write. All right. So just make a little note here. So we're going to have a function that's going to return an int. And we're going to call this guy char2int. This will take a char as a parameter. And this guy will return the numeric equivalent to whatever char was passed in. All right. So let's go write that. We'll prototype it up here. We'll implement it below. All right, so now we have to think about how we can do this. I think we looked at this, we looked at the inverse of this last time, right? So I might create a string called map. All right, did I do better on the alphabet that time? Nailed it? Well, do have a PhD. So, all right, so now if I passed in the char 2, I want to return the number 2. If I pass in the char A, I want to return the number 10. How might I take a string like this and make sure I return the right number? What could I do with this value? Don't even think about the larger problem we're trying to solve. We're just trying to solve this one little tiny problem where if I have the char representation of the number 2, it gives me the number 2. If I have the char representation of an A, it gives me a 10 as a number. So I've given you a starting point here. How can we use this to give me the right numbers? Any ideas? Go ahead. Yeah. Just loop through the string looking for the thing you're looking for. And as soon as you find it, tell them where you found it. You'll find the char 2 at bucket 2. You'll find the char A at bucket 10, so on and so forth. All right. So we're going to write a loop that goes through every character of a string. For int I is equal to 0. I is less than, in this case, it's map.length. And we do say less than map.length, not less than map.length minus 1, because we do want to go all the way to the end. The last legal bucket of this guy will be when I is less than map.length. Each time through, I plus plus. So again, this for loop just takes I on a voyage between 0 and map.length minus 1. Each time through, we're going to ask a question. Is map at bucket I, is the current character I'm looking at, is that guy equivalent to the character I'm searching for? So is map at bucket I equal to C? This uses the double equal sign. That's the equivalence operator. We're comparing it to my variable name C, which holds some char. All right. So if I found a match, what do I want to do? What's the value I found my answer, right? So if I found the char 2, for example, or I found the char A, what's the value I actually want to return here? Using A as the example, A is at location 10. 10 is the value we want to ultimately return. Which variable here holds that value? Go ahead. I. So we'll go ahead and return I. As we go through here, I was 0, I was 1, I was 2, I was 3, I was 10. When I found out that the character I was looking for was A, I returned the value of I, which is currently 10. Now, what does the return keyword do? Remind me. Go ahead. Yep. So, I mean, the obvious piece of it is it's our ability to return a value from a function, right? Hence its name, return. Okay. But the kicker, and this is important, and this is something it's so obvious that it's actually often overlooked. Return makes a function immediately end and optionally spits the value out. In this case, we are going to take advantage of that option. We will spit out the current value of I. But any way you cut it, when I had return right here, this function ends. It will not go through the loop anymore. It will not do any more logic. It ends. Make sense? Now, is that okay for it to end? Did we already find our answer? Yeah, we got everything we need out of this guy. So we really want it to end. It would be a waste of everyone's time if it kept spinning. We could have it keep spinning because we know it's never going to find another match, but it's a waste of time. So we'll go ahead and return I. Now, as this function is currently written, char to int, am I always going to get an answer from this? What would happen if I called char to int on a question mark, for example? Is it going to find a question mark anywhere in here? So I'm going to loop through that entire string, checking every single char, never actually finding a match. So I will never actually get into this if statement. That if statement will be false every single time. I'll find myself hanging out after this for loop, having no value to return. Notice a language like C++ will not scream at you in this case. Most modern languages will. Most modern languages will say, hey, you told me you were going to return an int. And there are situations in here where you don't. So if you want to follow good programming practice, If you've advertised the function will return a value, make it return a value or explicitly handle the problem. So in a newer language like Java and C#, you would probably, like for instance here, I might just go ahead and say return -1. We might say should never happen, but this makes sure it returns a value. We just happen to know we're never going to use this tool for a purpose it wasn't intended. We know we're always going to pass it some value between 0 and 9 and A through Z because of how we intend to use this tool, right? So we're not policing ourselves at all. All right, so we know that this should never actually get, we should never actually get to that line. But for completeness, even though C++ wasn't yelling at us, we probably want to get into the habit of making sure we always return a value. Now, in a newer language, like Java, for example, we might say throw, it would probably be like new exception. Why am I here? Something like that. So we wouldn't actually return a value, but what happened is if you ever got to this line of code in there, it would give you like an error message that you've customized to remind you that you are in a place that you probably shouldn't be. All right. But we're not learning about exceptions yet. We don't even have a language that supports exceptions yet. Hence this guy, old school C++. The whole program returns a number that's supposed to line up to some error code or something like that. We just pretend like that doesn't exist. All right, so for right now, I'll just go ahead and return -1 at the end. In the event I never run into that, we'll just forget about it for right now. All right, so just to test this, if I go and say cout of the char2, we should get the number 2. If I say cout of the char A, we should get a 10. There's our 2, there's our 10. So we've brought that tool home from Home Depot. We've tested it out to make sure it works the way we want it to work. Now we can confidently go in and start using it inside of our program. All right. So we'll come down to base to decimal. We already know we're walking through our string backwards. I probably want to go ahead and say something like int val is equal to char to int of number at bucket I. And if we want just to prove to ourselves what's happening here, we'll go ahead and display what val is each time. So my current call here is BAD. So this should give me a 13, a 10, and an 11 if it's doing this lookup correctly right here. I'll go ahead and dump these two couts. So there's my 13, my 10, and my 11. So we're getting the right numbers out of that, right? Okay, now what do I want to do with those numbers? I want to multiply them by the current place we're in. I took the ones place times that number. I added to that the 16s place times that number. I added to that the 256 place times that number. We already have something changing place from 1 times base is 16 times base is 256. So we're already taking the variable place on that voyage. We're already taking I on the voyage through here. We already have the ability to look up a D and get a 13, to look up an A and get a 10. Now we just need to bring it all together into summing some stuff. So we're going to have to keep a variable for holding our ongoing sum, our running total. So I'll go ahead and say int sum is equal to 0. And each time through here, we want to go ahead and say sum is equal to sum plus the current value of place times the current val. And then make sure we also multiply place by base. We had taken that out. So each time through this loop, we're going to get the numeric equivalent of the character we're looking at, multiply it by the place, add it to our ongoing sum. Make place bigger than it used to be. As soon as this loop is done, our final answer should be inside of a variable called sum. So this should be 2989. If we were calling it on BAD 16, if we were calling it on 1, 2, 6, 7, and 8, 1, 2, 6, 7, base 8, we expected to give us a 695. There's our 695. If we were to call this guy on 1, 0, 1, 1, 1, 0, base 2, 1, 0, 1, 1, 1, 0, is that all of it? And this is base 2. We're expecting a 46 out of this guy. And there's our 46. All right. So questions about that process?
Yeah, could I take a look at base to decimal again?
Sure. Right down here.
So from looking at it, how does it know to like do the conversion?
Well, I'm giving it its inputs. I know that when I wrote this, my intention is for this to convert this number into decimal. That's my intention. That's the problem that the human programmer is trying to solve. So in order to do that, I need you to give me a number and I need you to give me what base that number is currently in. It just so happens the number you've given me is in a string. So I need to work with the format that you handed it to me in. So that's when I start putting my things in place that allow me to emulate this problem solving that we practice on these slides. It allowed me to keep track of the place. It allowed me to keep track of where I was in the string. It allowed me to keep track of a running total. It allowed me to map between like the char 1 and the number 1, the char 0 and the number 0, the char D and the number representing D, like a 13. So all this logic is meant to emulate the way we've already reinforced that we know how to solve this problem as a human being. So we practiced solving it 3 times with 3 kind of different inputs, made sure we saw the consistent pattern, and then this is our version of that pattern. We're saying, remember the ongoing, the running total, remember the sum, remember the current value of place, loop through everything in your string from the end towards the beginning, because that's where the ones place is at the end. Each time through, give yourself the numeric version of whatever char you're currently looking at. So we're calling our other function we wrote that does that little mapping. Then multiply that value by whatever place you're currently in and add it onto your running total, which we're storing in sum. And then make sure place becomes bigger than it used to be. So if we're dealing with base 2, the far right is the ones place, times 2 is the 2's place, times 2 is the 4's place, times 2 is the 8's place, so on and so forth. So this is us changing place. That's us making this change, this value to this value to this value. And then when all is said and done, our final answer should be inside of sum, and that's what we're returning. So all of this logic here is emulating the way we have solved as a human being how we convert a value from some other base to decimal. And this encapsulates that solution. This is the C++ syntax, or a example of C++ syntax that will accomplish that job. that make some sense?
So if place times base turns it into the number, or is that place times val?
Well, place times val is doing this part. It's doing place times val. Place times val. Place times val. So val is changing each time through there. Place is changing each time through there. And we are keeping those changes, we're keeping the running total inside of our variable called sum. So this
So
is,
then,
we remember that. Go ahead.
right. So then what is place times base doing?
Place times base, first notice that it's place equals a new value. The new value is whatever place currently is times the base. So place times base is changing this 1 to a 16. And then the next time through, it's multiplying 16 by the base again, which is making it a 256.
Okay, I get it.
Okay. Lots of moving parts, right? And that's why we took little tiny baby steps as we did it. It's still supposed to be uncomfortable. When you see it, it should still make a lot more sense than you just sitting down and doing it. But I promise you, you'll be able to just sit down and do this pretty easily before too long. You're just still wrapping your mind around how do I mean, already it feels annoying how slow we're having to go through every problem, right? But we almost have to do that as beginning programmers to make sure we don't skip steps because we're not skilled yet at quickly solving those things in our head. Eventually you will be, and then you'll have the new problems that are difficult to solve inside your head. So somewhere I have a cap, right, where I'll have to start drawing a picture of something because whatever thing I'm solving is complex enough that I can't just on the fly have the 50 lines of code in my head that I know I need to do. I need to think through it a little bit. Or something like this is not difficult for somebody who's programmed for a while, but you'll always have that one that's too hard. That you're going to have to draw the pictures, that you're going to have to take these little baby steps. So even today, I use this skill sometimes, slowing things down. The good news for you is that most hard problems are made up of a bunch of easy parts. So if you were to go and look at the source code for like Microsoft Windows 11 or something that you perceive as a really complex problem, you're going to see for loops that do int I is equal to something, I++. You're going to see stuff you've already seen sitting right there in the middle of really complex programs. All hard problems are made up of a bunch of easy parts. There's just, instead of 2 or 3 little things that are happening each time through, there's 2 or 3,000 things that are happening each time through. So there's you're kind of juggling a lot of balls at once. All right. All right, so any other questions about this guy? Good. Yeah, so if I were, so here, let's just see it as an example. So I'll go ahead and I'll just do a cout char to int. I'm going to pass it a question mark. So if I pass it a char that is not found anywhere in my string, which we wouldn't expect to ever run into a question mark in the problem we're solving. The problem we're solving is converting numbers between bases, right? We expect there to always be either numbers there or a letter of the alphabet. Question marks aren't allowed, okay? But technically, question mark is a char. Somebody could pass that to your function if they weren't using it right. All right, so the issue here is that we have advertised to C++ that we will return an integer. We should get into the habit of fulfilling that promise as a good programmer today, because older languages like C and C++ will not yell at you if you forget to do that. But if you forget to do that when you really should have done it, because things have default values, your program might get a 0 out of this. Typically, the default value for an int is a 0. So let's say you're relying on this for doing multiplication, as we are, right? All of a sudden, you're going to get weird answers because it's always going to give you a 0, even though you never return that value. It's going to return zeros for you. So I'm purposely saying here at the end, look, if I'm still alive here, kind of like think about this like a minefield. You know, you're tiptoeing through this minefield. That's our program here. And if we somehow make it through that for loop and we're still standing and we don't know why we're here, because our expectation was we were going to get tripped up right there, right? In the middle of that loop, we were pretty confident we were going to bump into some character that made up our numbers. But if we happen to call this guy with something like a question mark where it's never going to find that in here, we eventually will get down to this guy. And I'm returning -1 there as an example of I promised I'd return a value. Now, if you wanted to give yourself a little visual feedback, kind of as a reminder for you, because I mentioned that older languages like this don't have a feature of most new languages called exception handling. You might just do something like cout, I never found the char, check the number. Something like that. Maybe even put some asterisks or something before it to have it stand out, right? Then go ahead and return your -1, which to your point, you said it's a meaningless number, right? I just picked a number out of the sky to return -1, probably for doing math, doing math with it, it'll flip something negative that should stick out like a sore thumb for us. But throwing a little comment out there is not going to be a problem either, because we fully expect us never to get these lines of code. We expect to hit this return statement, which makes functions immediately end. Therefore, we hope we never see this. But as I have it written right now, I am outputting the result of char2int on a question mark, which it will never find in here. So what we should see to the screen is this little error message we just wrote. And then also, since we're returning a -1 and I'm outputting that, we'll also see the -1. So there's my little message, and there's the -1. Make some sense? And again, just to re-emphasize as well, if you didn't do this, it would not be incorrect in this language. This language allows you to just not return a value if you don't want to, even if you've advertised that you will. I'm telling you that is bad programming practice. And if you get into the habit of that, your bugs will be much more difficult to find. All right, other questions? Go ahead.
String that. So what is that?
Well, first of all, remember, so he's asking about this variable here. Why did I use that variable there? Now, we didn't have to do that. I mean, we could have solved this problem a different way, but let's think through this. The job of the function that I'm currently writing here, char2int, its job is I pass it a character, like the letter A, and it gives me back the numeric equivalent of that. So if I gave it an A, it should hand me a 10. If I gave it the char2, single quote, 2, single quote, it should hand me back the number 2. Because remember, if I do math with the char2, I'm not going to get what I expect. So if I'm up here and I say cout 2 plus 1, what answer am I going to get here? Notice I wrote the char2 here rather than the number 2. Those are, ninja. Those are two different kinds of values. One's a char that has an ASCII value behind the scenes. One's a number that has a numeric value. So I get a 52 there. Why did I get a 52 there? I'm guessing if we go and look up on the ASCII chart, we will find the ASCII value for the char2 is 50. And we added 2 to 50, which got us a 52. We don't want this treated like a 2 like that. We want it treated as a real 2 that we could do math with. Now we should get a 4 out of this. Make sense? So your question was, how are we using map to accomplish that? Okay, so this is kind of like our math trick for this one. We put in a string, a list of all the characters we might run into in a very specific order. We put at bucket 0, the char 0, at bucket 1, the char 1, at bucket 2, the char 2, at bucket 10, the char A, at bucket 15, the char F, so on and so forth. So that whatever character you passed in, I could just search through this string looking for that character and then tell you what position I was in when I found it. When I found an A, I was currently in position 10 of that string. So I'm doing like a little math trick. This really isn't a programming thing. This is you sitting there as a human being trying to devise a little trick of, well, if I lay out some flashcards here and I want to find out, what's the numeric equivalent of something? Well, I have to go all the way down to A here. Which flashcard was it down here? It was the 10th one, something like that. You're just looking for ways that you can emulate your problem solving. Because otherwise, when you're solving this yourself and you're looking at something like this, you're doing that lookup yourself. You're just doing this like a human being. You're just saying, okay, well, it supports 0 through 9. So the very next one is A, that's a 10. The one after that's a B, which is an 11. The one after that's a D, which is a 13. You're doing a lookup somewhere. You're just doing it so quickly, you don't really realize how you're jumping through that. You already know that 10 comes after 9 and 11 comes after 10 and all these things. You're trying to emulate that. All right, other questions? All right, so at this point, we've seen several examples of us solving real problems that we wrote in class and did something with. One thing you're going to see as we go through and you start working on the functions that I gave you for the assignment due next Thursday is I think there's something like 15 functions I think I gave you. Quite a few. But again, those are practice for the midterm. You will find them extremely helpful for studying for the midterm. All right, so I wrote the midterm at the same time as I was writing all those functions, and I just wrote more functions. And I picked 15 of them to be on the assignment, and I picked 10 more to be on the midterm. Very similar, okay? So it would be very good practice to go through those, but plan on spending some time. So maybe do a couple per day or something like that, just to keep your mind drilling and then get ticked off at yourself because you just don't know why you're stuck, yada, yada, yada. But the kinds of problems that I like asking tend to be things that are small enough like this where you can conceptualize it in your head. Yet they're complex enough that it forces you to do like 2 or 3 or 4 steps to accomplish an algorithm. And once you're comfortable with that, you can pretty much program almost anything with enough planning. All right. So for example, let's say that there was something where I wanted you to remove vowels. Okay, I think we maybe even wrote this before. Well, in order to remove vowels, I need to first have a detector that will tell me whether something is a vowel. Right? Well, so we can kind of use a similar trick there. So maybe I have a Boolean, it returns a Boolean. Maybe it's called isVal. It'll take a char as a parameter. What I'll do in here is I'm going to go ahead and I'll name my string map again, but here you can call it vowels. We'll name this string vowels because it's going to hold all the vowels. Now, if we pass a character into this guy and we want it to return true, if the character we passed in is a val, really what we're saying is I want to return true if whatever this guy is found in here. So we'll have our normal loop where it I is equal to 0. I is less than vals.length. I plus plus. So we'll take I on a voyage from bucket 0 to bucket 1 to bucket 2 to bucket 3 to bucket 4, so on and so forth. If vals at bucket I, if the current character I'm looking at is equivalent to the character that was passed in, that means it must be a val. If I found the character you passed in somewhere in my string of vals, it's a val. So I'll return true. Remember, return makes the function immediately end. If I get past this entire for loop, that means I have searched every single character in this string and I did not find a match. Therefore, this guy is not a val. A little comment. Make sense? So you can create little detectors like this. So then if we go to write the function like remove val, I might return a string. Maybe this guy's called remove vals. They'll take in string s as a parameter. So when we're dealing with strings, we typically build up a string off the empty string. So you might rethink about remove vals as keep non-vals. So anytime I run into something that's a val, just move past it, ignore it. So I'll have my answer. We'll start off as the empty string because we build up strings on top of the empty string. We'll search through. Well, we'll write our loop that goes through every character in our string. Takes I on that voyage through the indexes. Each time through, we'll ask if is val s at bucket I. If the current character I'm looking at is a val, we don't want to do anything with it. Therefore, we only want to do something with it if it is not a val. And if it's not a val, we'll tack it on to answer. So as we've done that for every single character in our string, only keeping the things that were not vals, we'll go ahead and return our answer. And now we have something that returns or removes vals. If I say remove vals and I say hello world, have that print that guy out, there's our hello world with the vals removed. So you'll find that the patterns of manipulating strings and things like that tend to start repeating themselves, and you'll start putting these guys into your little toolbox for problem solving. Okay, so again, remember, we will not meet for class next Tuesday or Thursday. You do have a big homework assignment that's up that is geared specifically to prepare you for the midterm. That exam is due a week from, or that homework is due a week from today. The exam, the midterm, will be live on Blackboard starting at 10 a.m. on Tuesday. You just need to take it sometime between then and turning it in before class the following Tuesday. So pick your favorite time during the week. Do yourself a favor and do it yourself. Don't work in groups. Whether you get through this class and get burned later on, it's on you, not me. I don't care. All right. But I am going to be around. I will release a video probably today or tomorrow with the solution to all those things from the homework assignment. So if you want to peek ahead, if you run into trouble, you can. Otherwise, I will see all of you in person a week from next Tuesday. But I'm around via email, Slack, all that jazz. All right. All right. I'll see you when I see you.